Okay, so we're here today. We're looking at Physics Classroom SE3, Static Electricity 3. We're looking at question 1, and we're kind of going to look at question 1 and 2. And when we look at this, I know this is hard to read, but you'll have it on your screen as well. This one is asking basically about two ping pong balls that have metallic paint, and they come into contact. And it gives us the charge of the ball. One is negative and one is negative. Two different numbers there of charges. And it says determine the force of electrical repulsion when held a distance of 43 centimeters apart. Now, to do this, you're going to just use Coulomb's law. This is an equation that you should have from your notes. Coulomb's law is an equation that allows you to come up with a force of attraction or repulsion. All you need to know is that K is a universal electrostatic constant. This is never going to change. It's 9 billion, 9 times 10 to the 9th. F is, of course, that force. And then we have the two charges, Q1 and Q2. This should always be in coulombs. And then D is the distance between the charges, and it's going to be measured in meters. So when you're doing this, a question like this, I recommend just starting with some paper. You always want to write that down, and you want to make sure to put down your equation. I went ahead and wrote that down for us. You want to make sure and think about your equation. You want to think about SI units, and you want to think about variables. And in a lot of cases, a great starting point is just writing down variables and kind of start with what you know. And so on this question, I'm going to be writing down what I know. And so those variables, it gives us, it actually asks the force of electrical repulsion. That's the ultimate question. So we can show that to be, of course, a question mark. In the course of the problem, it gives us a couple of charges. We can call them Q1 and Q2 because it gives us a couple of those. And I went ahead and wrote those down there. Those, of course, come from the question itself when it says how the charge that is on the balloons. Remember, we do have an equation for electrical force, and in that equation we have this K, which is a constant. We always know that. So we can go ahead and put that down. K is going to be 9 billion. And then the other thing that we're given in this question is they tell us that they're 43 centimeters apart. So distance is 43.3 centimeters. And this is critical. On this one, it shows 43.3 centimeters right here. But come up with equation, variables, and then SI units. This is a really big deal. Were these charges in SI units? So if we look back here, what is the SI unit for charge? It should be coulombs. Did it give us this charges in coulombs? It did, in fact, because it labeled it as C. And in fact, it labeled it as C, so we're good. Now here we have centimeters, and this is the thing a lot of people miss on this. The distance, the SI distance of unit for distance is the meters. So this is a really big change. You want to make sure and fix this, and note that this is 0.433 meters. A lot of people miss that. Now, if we look at here, we actually have four things. We have one unknown, so we should be in great shape to solve this. Your equation, as I wrote right here, is F equals K times Q1, Q2 divided by D squared. If I go ahead and put in everything I know, it should be pretty simple and plug and chug, but I'll show you that. So I went ahead and put in everything that I know into that, and this is just a simple arithmetic problem here, really. So at this point, you should be able to solve this. Now, I will give you some words of caution here, just like before. I would recommend either working all of these numbers out and inputting them separately into a calculator a step at a time, or if you do try to do it as one giant input, which is ill-advised, you've got to pay very, very close attention to parentheses. Again, I would over parenthesize things and brackets and whatnot. You're never ever going to hurt by putting too many in. You can certainly get the wrong answer by messing it up. One final note, I'm not going to solve this. I would expect you to be able to. If you need help working through something like this on a calculator or solving this, I can certainly help you, but that's not the scope of this video. You did start out with a negative charge and a negative charge, and in here when we get to the end, you're going to end up with a positive number for the force. I will say, and that's going to work fine on your positive. On here, you would just put the positive number in. You're going to put it in scientific notation. One quick note about scientific notation. Say you have the number 586, pretty big number, number 0.00586. Both of these, if you put it in scientific notation, you're going to end up with 5.86. This top one, to get it to 5.86, you're going to end up having to move the decimal place that way twice. So this would be times 10 to the second. And this one, you're going to have to be getting a lot smaller. So here, you're going to be moving 1, 2, 3 to the left. So if you were doing that one, that would be times 10 to the negative 3. And so when you're inputting these answers into physics classroom, or for that matter, just understanding scientific notation, you would enter times 10 raised to the, and then you would put a negative or a positive and then that exponent. One final note on this one is, if this one has a negative charge and a negative charge, and we know that positive and positives or negative and negatives repel. If you run a calculation through this equation and you get a positive number, that would be a force of repulsion because you start out with like charges. If you run it through and you end up with a negative answer, that's going to be a force of attraction because you're going to start out with opposite charges. So a positive and a negative, or a negative and a positive, or a negative and a neutral. And again, we know that if there's just one charge thing involved or opposite charges, they're going to attract. And so if you do run this through and you end up with a negative value, that's actually a force of attraction. A good rule of thumb is don't worry about the negatives and positives on the charges. Just remember opposites attract, like charges repel, and just think about the attraction at the end. And towards that end, physics classroom, even though this one technically would be a positive answer and this one would technically be a negative answer, it's looking for a positive input on here on both of these. So you're basically just doing the absolute value. All right, one final note on the last question. I believe it is question 7 on Essay 3 like we've been doing, but question 7, it's a little bit trickier. It gives you a similar scenario. It talks about two things getting electrons. It doesn't really give you coulombs. So remember, when we started here before, and you started inputting your variables, this was from question 1, those two charges started out as coulombs. When we started out there, we were in coulombs. This final question ups it a little bit, gets a little bit trickier, because you'll notice it just gives you a total charge of elementary charges. So what you're going to want to do there is you have to convert, you have to use these conversions right here and the process we used. I showed you that process if you're not sure how to do it in the video on SE1. You did several conversions. But you're basically going to have to go from the elementary charges, and you're going to have to go 2 coulombs, and then you're going to have to put that in here. This is basically the exact same thing you did multiple times in SE1, but that's a critical step. Once you do that, then you solve it in much the same way as you solve the previous ones. The one thing that sometimes confuses people is when you're inputting this, again, you got to make sure that you go into meters, but Q1 and Q2 are the same as each other. So once you find the charge of one of them on each balloon, whatever your answer is for this, that's going to be Q1, sorry about that, Q1 and also to Q2. So these are identical, so you could put the same number there that you found. And that's how you would work this one out. Thank you. I hope this helps. I hope you have a great day, and I will see you in the next video.